I've started the recording. The recording is on. This is the lecture for Design 330. It's Tuesday, the 23rd, and we're going to go over a few different things. The first thing I wanted to do, though, is for those of you who were either at the seminar or have had a chance to watch, excuse me, what we posted on it. This is one of those maps that this was where they were trying to send us to this link, and I'm not positive it really got there. But this is a map of Sacramento, and this was from, I think it's 1933 or 1930 something. And you can see these are I picked an area that was redlined, and these are those remarks that they were talking about. Um, uh, Japanese colony, concentration of Negroes, no deed restrictions. That was sort of code word for anybody will be allowed to buy here, so you're not protected. State Housing Act, violate grand jury heterogeneity. Now check this out. Predominance of subversive racial elements are the area's chief hazard. Low red gray. So, and like, what the heck is that? Subversive racial elements. Well, it turns out if you look closely, that meant Orientals. That they were somehow considered subversive. Not really sure how. And if we go down here, look at this. Infiltration of Orientals has occurred. I told you when you read these things, it's like, it's explicit. It's not hidden. It's not, shied away from. It's whack right in your face. And this is telling the federal government not to provide loans in this area because of this infiltration of Orientals. And look at this high rate of foreign, Japanese, Negro, 10%. And then it goes, oh, what's favorable? All these favorable, detrimental. And there it is again. Presence in large numbers of subversive racial elements. So you can't say that this is based on economics. It's based on race, which is a weird social construct anyway. Declining 10 years. And then if you look this up, I think I can do subversive racial elements. Search the city for that. I think it comes up with map options. Let's see, full map grid. Well, there I got to a spot that had, oh, I know what it was. Infiltration. Look at this. If you click on infiltrate, subversive races have occurred here. Has occurred here. Has occurred here. Orientals has occurred. Orientals rapid. Oh my gosh, it's incredible. So I just wanted to bring that up, that it's right there for us to look at. And here's the main site for it. And we'll be taking a look at that. And of course, we're interested in this with respect to water. Now, in I don't know how long the Franklin wastewater treatment plant has been there, but I remember supplying pumps for it when it was first being built. So that would have been late 80s, early 90s. All of these areas had their own pumping stations and their own wastewater treatment systems. And it wasn't until the late 80s, early 90s that we got really a modern one that served all the areas. But it still didn't really serve all the areas quite right because they all had to tie in. But what's of interest is that if you look at areas along the river, um, before the Franklin wastewater treatment plant came on, there were areas of high pollution and low pollution based on stuff dumping into the rivers, because it was sort of like, well, who cares? But guess what? These people were not just dumping into the river, they were getting from the river. And the worst spot was right here. They had a pump intake station right there. And all of these redlined areas, they didn't have good sewer systems. They were just dumping right in. And the dumping point was upstream of the intake point. Pretty bizarre. And I think it was cryptosporidium was the bacteria that was really bad, and it was actually affecting West Sacramento really badly too. So West Sacramento put new pump station in up Elkhorn over here. Cryptosporidium is a real bummer little bug. It's very small, and it almost takes reverse osmosis to filter it out. And it basically um, gives you diarrhea so bad that you dehydrate your own body and you can die from it. It's got a fairly high mortality rate. But you know, I believe it's a bacteria, so they do have bacteria antibiotics that can get rid of it. I think it has to be very specific. If I remember, it's a bacteria. So anyway, water quality has a lot to do, and where you lived in Sacramento depended on whether you had good water or not. And that's why we're talking about all this. We want to understand our market so that, and I mean, we're taking this from from a, hey, I want to sell pumps and sell my service point of view. You have to have all this background knowledge if you're going to be knowledgeable about where you might be setting up your environmental scans and your environmental systems. So that's a little bit about what we went over. We do have access to the map building technology now. I think we just met with the company that is going to give us that access, and Professor Saka is going to actually show us how to work with it. And we are hoping to have 3 or 4 positions in the design hub in the fall for working specifically with this type of data for many things. So there we go. Any questions on that? Anybody have questions or comments about the seminar yesterday? Okay, we'll go ahead and move on. So here's what we've got going today. We're going to talk about what to do this week. So here we go. There's our what to do list, and you'll see we have a playlist. We have a video playlist that's coming, and you know, there's not that much here. You can go through this playlist in less than an hour, except for the social justice one. So I'm really keeping it short for you this time, and we'll have the 2 lectures added into here too. But the video playlist is fairly short. I didn't make a preview. Sorry about that. I don't know why I didn't do that. We have a folder that has your work in it. So if you did not make a set of your own, okay, if you just didn't get it done, and I know there are a few people that have had still having issues with power and internet from the storm 2 or 3 weeks ago, and I believe it 100%. Because I've battled through my own issues with that. And so here are copies of everything that you need to be able to move forward this week. So those are there for you. And here's the milling machine simulation. You're going to make this shape right here, and I'll zoom in on it. It's no longer a block, it's a block with a cutout. And I very specifically made these 2 dimensions as they are. And I'm not sure you're going to be able to measure that. So I do have one more thing to do. I've got to give you a little tutorial on how to take your snip, put it into AutoCAD, and take your measurement. And I think I've done that, but I'll do it with one of these so that you can see how to do it. And we'll talk more about this later on. But now you've got 1, 2, 3, 4, 5 dimensions that you have to hit. And I'm letting you know that this E dimension, this E diameter here, is really a milling cutter diameter. So you just need to get the edge of your milling cutter to a certain spot and then come down to a certain spot, and you'll be able to get it. Okay. So that's what we've got for your milling assignment. And I'm expecting that to take 45 minutes to an hour. And then we've got your template to go through. So let's take a look at what your template is going to look like this time. There is a part 1 and a part 2. So you're going to see that, part 1 and part 2. This all looks the same. So this you should be getting familiar with. How many hours you plan to work here, how many hours you actually did work. And remember, your deliverables are page numbers. Those are your deliverables, or not page numbers, but item numbers that you've done. So you'll want to look this over. Okay, so for part 1, you're going to do an assembly drawing, a rendered view, and an exploded view. And the exploded view can be a single page, or you can do what we call an animation, either one or both of those. So those aren't too bad. The assembly drawing, the rendered view, and the exploded view. And I've given you a video on each of those of how to do it. The most important, of course, is the assembly drawing. But when you come to present it, and often the engineering department works with the marketing or sales or packaging group to make nice rendered views. And the exploded view is often used in assembly or instruction manuals or maintenance manuals. So it is important to know how to make an exploded view. And Inventor makes it very easy. The exact same tools exist in Fusion. They exist in SolidWorks. They do not exist in AutoCAD, but AutoCAD has some plugins that allow you to do it. So if you're doing this in AutoCAD, you can either do it by hand or use a plugin. But I'm going to show it to you using Inventor, which is right over here, which, you know, they always make our sessions so short. So I'll be able to show you in Inventor how to do that. And we'll probably do that on Thursday. We'll work on some other stuff today. Okay, so we'll be able to do it. And I'm using VMware so that you can too. So there's those 3 pages. I expect those to be fairly quick. And then for your additional items, your part 2, we've got something called a process specification sheet. And this is going to set us up for the next 2 to 3 weeks worth of work. And every company has something kind of like this. Some people put it in a product book or a stick file or a binder or a product folder or a sales order folder. But there's something that tells you how to build this product kind of from start to finish. And our process spec sheet is sort of short, and often it's got parts, but you're going to see that we want something that tells us, okay, I got this assembly, kind of how do I make it? And then we've got your milling assignment number 2 to put in here. So not too bad. Okay. So what I'm going to ask for in your process spec sheet is a bill of materials, a little bit about production control. And by that we mean how do you control the process of making it? And many companies use something called work orders and purchase orders. If it's a part that needs to be bought, you purchase it. And that's how that purchasing process controls how you get purchased parts. And a work order controls how you make parts. So we put those under production control. And then we've got an assembly and test process that we want you to go through. And then we've got the assembly process information. I think I've got those. I think I've got that in there twice. I'll have to take a look at that. Assembly and test. Oh, no, got it. This is part of what we have to do. And then this is part of your assembly process. Okay, so we'll show you all those. This is important. This is your thinking through how a product gets made. And there is no right way to do this part. Every company has their own way of doing this, from very small companies that are just yourself, where you basically have it in your head and you do it and you go, oh, what do I need to do next? To a large company that's spread out all over the country or all over the world, and you have to communicate very clearly and very well. And some have just-in-time manufacturing where, man, I need that stuff exactly in the right place at the right time to do the right thing. And there's tons of work behind doing that and logistics. So it goes from the most simple, I just got a shop and a bench and I make this stuff, to something spread out all over the world. But everything has something called the process spec sheet, whether it's a napkin or a large computer program. So we'll talk about those things. Okay, so that's what goes in your submittal. Fairly simple one this week, like last week's. Last week's was pretty simple too. Okay, so there we go. Any questions on what sort of due at the end of the week? We can actually go into the specifics of it. Okay, let's take a look and see what we're going to do. This is sort of the order we're going to go through. So we've been working on parts, right? At first, we just sort of researched and go, I wonder what our parts are supposed to do. And then we kind of made some examples of those parts, some base designs. And then we made the parts that we wanted to be able to make based on our research, which was, I need a 1/2 inch this, a 1/4 inch that, a this, or that. And then last week we made not just the parts, we made the drawings for the parts. So we're slowly working up to the point where now we're ready to talk about assembling those parts. Okay, so now normally we've taken 4 weeks really, to get to this point. Most of this work, if you were in a real, kind of fast-paced, moving design environment, all of what we did in the last 3 or 4 weeks would be done in 3 or 4 days. Okay? And you would have a lot of stuff available for you to work with already. Very rarely do you make some product from scratch that you have no experience with when you're working in a company. The company's been there for a while and they know how to do it and they know how to get going. So unless you're working with some sort of a startup and you're sort of kind of helping them get off the ground floor, there's a lot of information. Okay, but it's fast paced and it's moving. And so we've had the luxury of going slowly, and we'll continue to go slowly. So all of this would pretty much get done in a couple of hours. But we're going to take a week to get it done. Whew, that's good, right? So the first thing we have to do is create our assembly model. And I'm going to show you a couple of tricks. And look, I've designed this thing as almost all cylindrical joints on purpose. They're the easiest thing to work with. And guess what? If I can design it and assemble it easily in CAD, it's easy to do on the shop floor. Okay, keep that in mind. I know we like really cool looking fancy stuff that's complex and all this kind of stuff. If it's easy to put together in CAD, it's easy to do on the shop floor. Now I'll tell you about a near disaster that I worked on. I worked for a company called Tri-Tool, and we made portable pipe cutting equipment. And we had an incredible salesman that sold to Houston Light and Power a Victaulic, a portable Victaulic groove coupler. So Victaulic is the name of a company that makes couplers that are somewhat flexible, and you cut a groove in each end of the pipe, and you clamp this thing around it and put a seal in there, and it locks into those grooves, and it makes you a seal, and you can put pipe together that way. And they're really cool. And Houston Light and Power had a nuclear power plant that they were building, and they wanted these things. But they had already built their system, and then they went back and looked at the drawings and found out it was supposed to be couplers that they could remove, and it was all hard built. So they wanted us to cut the pipe, cut the groove on the end of the pipe that was already there, cut the groove on the new spool, and put it into place. And we said, sure, we can do that. He says, good. I sold it, and they want it in 4 days. What? We had no, so we did this crash design course on it. It was my design. They threw it at me. Go get it done. Work with the R&D guys. Get this thing done. So I had to even find out what a Victaulic groove was, all that kind of stuff. And we did this really cool design, and it looked all great. And you actually couldn't put it together. You literally, the parts, I could show them inside, but there was no way to physically put it together. They had to like grow inside somehow. And nobody caught it until day 2 out of day 4 when we physically tried to put it together. And so it was like my boss came running down, said, you idiot, you know, and of course we worked for the next 72 hours straight and got it done. But that was where I learned, make it simple. He goes, this is way too hard. Here, do this. Oh, okay. And we did that. And it was all just simple stuff. Holes and threads and easy things to do. Okay, so I made this thing simple on purpose, and not just to make it easy for you to draw, but it's got to be easy to work with. So we're going to assemble the model now. Here we go. Not again. Man. So for the so Wasan goes, do you want the piston pump final drawing or the same drawing as I want your piston pump. So in the video I was what in the world? Why can't I get onto this? Hold on a sec. Let me get into here while this is coming on. No, so I was just showing sort of how to do it. And so for your exploded view, I want you to do the piston pump. And the example is just a quick sample so that you can see how to do it. And I am going to do, I am going to demonstrate. What? No, there it goes. Okay, good. So here we go. I've got all of my parts somewhere. They're in a folder. There's a folder right there. They're in a folder. So I've downloaded them and they're all in a folder. So I'm going to make an assembly. And I'm just going to show you, and I'm going to do part of the assembly just to show. I think in this one I showed you how to do the whole thing. Oh my gosh, the VMware is really going slow. They must be having troubles on campus. Okay, so we put ourselves into a space and we make an assembly. So I have to go find it. There they are. And I spelled work wrong. And I'm going to start with the block, but it's not going to take too long to do this. Click, right click, OK. And then I put in my next part. And there's a video on how to do this. So I'm only going to talk about a little bit of it. And the next one is a nipple, 1/2 inch close. And you're going to work it with the whole model. And then I go ahead and make my joints right away. Personal preference. Many people keep going, and these are all cylindrical joints. And so I'm going to put the center of this face right here, the center of that face on the center of this face. And I do it that way on purpose also. Okay? I usually go face to face, and then I'll go do my offset. So I double click on it and I look at this arrow. The arrow says pointing outward is positive. I want it to go inward. So I'm going to go minus 0.25. There we go. And so that's in place. And so now I can put on my check assembly, 1/2 inch check assembly. And I got to pay attention to the direction when I put it in here. So I'll put it here, click, right click, OK. And I see the arrow says it goes that way. So this end, the outlet of my check goes to that nipple I just put on. So when I do my joint, I want to make sure that I do a cylindrical joint of that end up to here. And up, it's going backwards. So I have to flip it. Flip. There we go. And now I can open that one and double click on it. And look, I'm going to do two things at once now. I'm going to move it in minus 0.25. And I'm going to go minus 45 degrees. And the reason is I want to be sure that I can see that arrow from the top view and from the front view, so that I'll be able to catch that. I didn't do that in my other one, but in this case, that's what I'm going to do. It's a little easier. Okay, so now I'm going to put in my next piece, which is another nipple. Oh, wrong one. Escape. So let's see. Wasan says, so if you need to change it, you do what I just did there. You come in here and you double click and you use this angular rotation and you just spin it until it gets to where you need it to be. And it just, I can't tell you where it's going to go. But this angular rotation spins it. Okay. And you'll be able to either go like 180 degrees or 45 degrees or 90 degrees or something like that. So that's a good question. And so now I need my close nipple, 1/2 inch. Okay. And this one doesn't matter which way it goes, but I'm still going to use a, and because I'm using a cylindrical joint, I can do that angular thing. If I used a different type of joint, it wouldn't let me do that. So I'm going to do this cylindrical joint that I just put on. And I'm going to go again, minus 0.25. And I'm going to put on the last piece I'm going to put on, because I want to get on to some other stuff and talk about it. But this is going to be my 1/2 inch inlet filter inlet, 1/2 inch. There it goes. And this one I'm also probably going to rotate a little bit. Okay. And so I'm going to put my joint on there. And it managed to put it on right for me. That's a nice thing. Apply. Now, as I look at it, I'm going to take a look and see if I'm in my front view. Is it going to look? That's actually okay. I can see those. And I can see them there. Later on, if you see from your view that you want to get that changed a little bit, you can rotate that also, right? You can come in and you can rotate that joint. I'll go say minus 45. Well, that was, it didn't do much for me. But you can see, I can move that around. I probably went the wrong way. Okay, but you can move where you put those holes later on if you need to. Okay, now I've got everything pretty well set here, so I'm okay. I'm going to save this file, save as, and I'm going to make this my assembly just so that I can move on. I don't need to show everything. You'll do everything. You'll do everything. Now, my way of putting this into an assembly drawing is to right click up on the assembly and create a new drawing view. And standard, and this is already set up. This one, I can do all this work anyway, but this one's set up. And assembly drawings are usually, Alex says, do I save it as a project or as an assembly? Well, in Inventor, I made it as an assembly. Okay, and my project, so when I go File, Save As, okay, it's really just asking me because I made it from an assembly function, it's going to save it as an assembly. If you're in Fusion, I think it's called a project, and your assembly is held within the project. Are you using Fusion or Inventor? Okay, yeah. So your project is really, oops, just going to cancel that. Okay, so it's already there for you. So I'm going to come up again here and go create drawing view. And I like their template that they've already got. So I'm just going to make that one. Yeah, I do want a BOM view. That's cool. The only thing is I just hate the way this all comes out. I don't care how it comes up. I'm going to put my own on. Okay, so I'm going to delete that drawing view. And I'm going to delete, well, that one's actually okay because it just happened to be okay. So, but often I'll delete it, but it needs to be bigger for sure. Probably needs to be 1 to 2. And I want a top view, and I want to spin it because I really want to get a section view of it. I'm working myself toward having a section view because I really want to see this as a section. So Jan asks, do you use the point? You use what makes a good assembly. You were supposed to have made an assembly that works. And so you should have a close nipple that works. On mine, it all goes together just fine with what my copy is. And so you use what works. You have to put together a good assembly. Hopefully that makes some sense. Okay, but now what I'm going to do is make my section view. Oh, no, I don't want that section view. I want, yes, I want that section view. There we go. Sorry about that. I do want that section view. And then I'll do something called suppress this view because I really don't want it. I'm really just making views to get me to what I want, which is a projected view, either this way or this way. That's what I really want. I want that projected view. And I'll suppress that one. So they're there. I'm just not looking at them. And I get this into a place where I can use it. Now notice, because I used a template that already had the bill of materials, it's already there. It's so easy to get now. And so I've got this. So you can see mine fit. There's a 1/2 inch NPT, 1/2 inch NPT, 1/2 inch coupler, a 1/2 inch check assembly, sorry, and 1/2 inch inlet. Okay, and this is already here. Oops, sorry, I'm boofing it up. The reason I want to get to this is I want to show you one more thing on why these parts lists are nice. Now, my parts list is a little bit big. I generally make these a little bit smaller, and I make this a little bit bigger. Usually, and I try to get it to line up so it looks nice on or near the crease. Now, this arrow is where somebody might fold this thing. Okay, so you might get a fold right there. So usually you try to keep important things away from these fold lines. So I might move this up a little bit. Come on, move. So the part's not on a fold line, or make the fold go through a part that's not really critical. I don't really care if that is on it so long as this stuff is away from it. Okay, that's a minor thing to know about. People might be doing folds. Okay, so the next thing though is to go to your annotate, and we auto balloon. And so when you auto balloon, you have to select your view, select a placement, select the parts, and then select your placement. And in general, I put them horizontal or vertical because it's just not that big of a deal of a part. And then you always have to come in. These are like, you can't tell what those are pointing at. They really don't do a good job. So you need to come back in and select these and make it real obvious what it's pointing at. And pointing at corners, our eyes don't pick them up very well. And I should have had this when I did the auto balloon. I'm going to undo it real quick. It says ignore multiple instances. On ours, we probably want to leave that blank because I would like to know what each one of them is. So when I've got multiple parts, Okay, so now I can come back in and put these in a good spot where you can see them, where it's obvious. I mean, it's really, you want to get it away from other parts if you get a chance. So these are just those things you want to make this clear and easy to read. Some places put them inside and you get that dot. That's pretty easy to read too. You have to get it away. Come on, move away and then get back on. So those dots are another way to do it if it makes it more obvious and more clear as to which part you're looking at. You're welcome to put those dots on there. Very commonly done. Well, so Alex said, too bad you can't color code the drawing. Actually, you do that in the presentation view, and you can, but in general, these are being printed in black and white. Now, most places are getting to the point where they've got a reasonable screen and they are just color coded. A lot of places are doing that now, but you would do that from the present mode rather than from the drawing view mode. And we'll go over that. That's what that present mode is for, and the exploded view drawing and all that. You absolutely can color code these, and it is better, right? And look, there's very few shops these days that don't have computers out on the shop floor, but they are, it is rough, and people do have slimy hands, and it is brutal on those computers. So a lot of places now just have monitors, and the foreman says what screen it's going out to. Anyway, so there we go. And you know how to fill this out. I'm not going to go into how to fill this out because you're already getting used to doing that. Click, click, and fill it out. So you guys just fill this out well. Notice that there are no dimensions and there are no tolerances. If you need to tell somebody about how big something is, you can do so. But in general, we don't do that on an assembly drawing. It's just not done. Okay. And we're not putting the notes on up here just yet. Okay. But here's the thing I want to show you how to do. I want you to show you how to export that parts list. Okay. Because you can make this actually an automatic function so that it whenever a change is made, it goes. But this, oh, that was edit. Sorry. I wanted to export. And I can make it go into a CSV, an Excel, you name it. So you'll pick how it's going to go. So I'm just going to call this table name parts list, file name, assembly 1, parts list, and I'll put it into an Excel. That'll be okay. I think. And now I've got it, and I can start using that. That's really important that you can pull from this, because where did this come from? It came from this. And where did this come from? It came from these. So now you are tied in real time to your actual design. So that functionality is what's critical, and it's what I did not show in the videos. So I'll probably pull this out and make a little video of it. Exporting the parts list is really important. You can do it in AutoCAD, you can do it in Inventor, you can do it in Fusion, you can do it in SolidWorks. Every place now exports these. So that's what I wanted to show you about assembling. And of course, you're going to do the whole part and the whole thing here. The reason I wanted it as the cutaway is so that you could see the piston that is inside this tube. Green corners around the drawing, like around this, around that. It could be that you're stuck in an edit view that's open somewhere. Let me see if I oh, here's the other thing. It always comes up with this other sheet that I just delete. I don't need that other sheet, that default sheet. Let's see. Do you have a part open maybe? So if I've got a part open, I see that part is green. So your view or a part is open somewhere. But when you print it, it won't show up green. But that's telling that you have something open down here, either in the view or the part. So you might have this active somehow, and you might be in some edit mode on it. Edit view. I'm not sure about why the whole view would be, unless it's trying to find something that you can't find. Sometimes if I so did you got it figured out now? Okay. All right. Well, I'm not positive. We might have to do some screen share during a meet to figure that one out. It should be okay though, unless it's locking you out from doing something. But if I have a part that's being edited in some way, so let me go into that. So I'm editing the extrusion. Still not doing it. I'm not positive why. We'll have to look it up. Okay. But now I'm going to show you the start of, let's see, I'm going to make this small. I'm going to come into here, and there we go. And I've got Excel on this machine. Otherwise, I would upload it and do it in Google Spreadsheet. But it doesn't really matter. So look, privacy option, I don't care. I've got here the start of my bill of materials. There's a few things. This is telling me that it thinks it's text, but it's really a number. So I told it it's a number. I'm going to go in here and make this middle center, and I'm going to make this a little bit bigger. Okay, now my next thing to do is determine the source for each of these parts. And the block housing, I'm going to make it. So I put an M for make or manufacture. The nipple, I'm going to purchase it. The check assembly, I'm going to purchase it. And the inlet filter, I'm going to purchase it. Those are key decisions that have to be made at the very first level of what you do. And now what I've got here is called a single level bill of materials. I wanted a multi-level bill of materials, which we are not going to do right now. I would put here that I am going to make it from brass 2 by 3 stock. And how much of that am I going to use? 1.75 inches. I'm just going to put 1.75. And that I'm going to purchase. So I don't have anything else to add to this. This has all the information I need to make this. That's called a multi-level bill of material. Because whenever I have something to make, I'm going to add in the information of what I'm going to make it from. Multi-level bill of material. Okay? We are not doing that. Does the bill of material include cost? So many, many, many shops include cost on the bill of material. That's an accounting function, and most of the places I worked did not. They had what was called a cost roll-up that read the bill of materials and did a cost roll-up, because I worked for places that the cost changed depending on how many I was going to make, how fast I was going to make it, and what work centers were loaded up. And so I tended to work for places that had more complex systems. So our bill of materials was essentially like this, and then they used the work order and the purchase order to worry about cost. Okay? So correct. So this is a simplified spot that we're just kind of counting what's made and then telling someplace where to go to find the next bit of information, make or purchase. But I did work at Ames before we were bought by Watts. We did include cost on the bill of materials. But then when we got swallowed by Watts, our system became much more complex because we had more places to work with. Okay? It's truly, truly, truly up to, hey, what works for your company and what have they done so far? Which is kind of cool. All right, but this is how, so I'm going to eliminate this one right now, delete. I just wanted to show that to you. This is the start, and I want to make that point that it comes from this, which comes from this, which comes from this. Okay? If you want to get really, whoops, wrong one. If you really want to start getting complex about it, this is just one version. But I might make this part out of brass one day, aluminum the next day, stainless steel the next day. So using Excel wisely is really important. And the way you coordinate and hold those is very important. So you can also imagine, Alex, that this would be interesting to have, but then there might be a column over here which talks about which version of this are you using. Okay, and they call that a build list, a build module, a build I'm blanking out, but I'll just call it build version. So build version is the most build option. That was the other one. because a lot of the places I worked on something called models and options. And so this was the model, okay, half-inch piston pump. And then the option held a series of codes for the different ways that I could put this together. Okay. And so then the build options were read by the computer. This held the build code. So it's really cool, actually. Production control is really, really, really cool. And I don't think we have any program at American River College that helps you understand production control, other than what we do, this little bit that you're hearing in this class. Production control is really, really a cool area to work in. Okay, so that would be called models and options. Okay, this whole thing, assembly one's part list, would be the model. And then this might be my brass option, or my aluminum option, or my stainless steel option, or my PLA option for those. And then I might even have this modeled and optioned. So I might have different levels of models and option, where if I pick half-inch, half by quarter, that might be one of my, I might have a series of options out here that tell me where to go. It's really cool, man. You can really get wild with it. We're not going to. There. That was a discussion to let you know that complexity is cool. We're doing SOS, start out simple, but we would never want to keep it simple. Okay? Yeah, it is much easier to learn simple. So there we go. So that's really lecture of what I wanted to cover for today. What we did is we went over, assemble the model, and create the assembly drawing, and we did export the parts list. So on Thursday, we'll very quickly go over the presentation, the exploded view, and the process sheet. Those should be pretty straightforward. You can look at those. Your rendering is like super easy if you've done any rendering at all. And for those of you who know other rendering software, you are welcome to use it. Many, many, many companies export to some sort of an OBJ or any kind of thing, and then they use Illustrator or Photoshop to make their renderings. So if you are an Illustrator, Photoshop, After Effects, Lightwave, whatever, if you do your work in those, 3ds Max, if you do your work in those, feel free. You do not need to use the simplistic stuff that you see in Inventor. Okay, if you have other skills. If you don't have other skills, then you're welcome to use Inventor. You could even take a screenshot, throw it into PowerPoint. Wasan, I think you've seen how much you can do in PowerPoint with, because you did the internship. PowerPoint has pretty good graphics, just simple rendering capabilities that make your presentations really nice. So if you want to do PowerPoint, you're welcome to do that. I showed A-Way, and Wasan, if you want to maybe throw a quick little presentation together about, you know, hey, here's 5 things you can do in PowerPoint. Take your screenshot, throw it in there, and do these things. That would be cool. And Jen, I know that you've got a lot of Photoshop and Illustrator capabilities. If you want to make a 5 or a 10-minute quick demonstration of what you might do, I would really love to be able to show those off, and you can add them to your your portfolio presentation. That would be cool. Okay, any last comments? I've got another meeting to go to, but any last quick comments? Okay, I'm going to turn